Okay, we're going to talk here about nuclear energy resources, and we're going to split this presentation into two parts. And so we're going to do up until advantages and disadvantages of nuclear energy in the first part of here. So we are still not really in the fossil fuel section anymore, but we're still in the non-renewable energy sources. Okay, here's a really cool video that I think you'll like. It's called The Most Radioactive Places on Earth. I'm not going to show it right now because it's a little long, but it's talking about ionizing radiation and where you can get exposed to that. And it's sort of surprising the different places that you would find ionizing radiation. So maybe we'll show that to you in class. Okay, what is nuclear fission? So we're going to look at here at how we get a nuclear reaction and what is it about the nuclear reaction that causes heat that will let us produce electricity. So what is fission? In fission, we have a neutron. A neutron is a particle from an atom, and what it's doing is it's striking a very large atomic nucleus. Not all nuclei from elements on the periodic table are stable. Some of them are rather unstable. And if you hit a neutron to an unstable element like uranium-235 there in the picture, then what's going to happen is it's going to break apart and it's going to release more neutrons and it's going to release a lot of heat energy. So what's happening in nuclear decay here is this uranium ion, uranium-235, very large nucleus, is decaying slowly over time. And as it decays, it actually turns into other elements over time. So you can see that the uranium hits with a neutron and it splits into a krypton and a barium. And then we can go from there. And this is called nuclear decay, and fission creates a lot of heat. So what happens here is that the more this happens, additional neutrons release more energy in a big old chain reaction, and it gets very, very hot. In a nuclear power plant, what they do is use all that heat energy from the nuclear fission reaction to produce steam. Like a coal power plant, you produce steam, and what the steam does is helps create electricity by turning a turbine and a generator and all of that. So there's a piece of uranium here that's showing you that what happens in a nuclear power plant, and they're going to use that uranium. 1 gram of uranium-235 contains 2 to 3 million times the energy of 1 gram of coal. So you can see that if I use uranium instead of coal, I get a lot more energy for the amount that I put in. Okay, let's take a look at more information about uranium here. A typical pellet of uranium weighs 7 grams. It can generate as much energy as 3.5 barrels of oil, or 17,000 cubic feet of natural gas, or 1,780 pounds of coal. That tiny little 0.24 ounce pellet of uranium produces a tremendous amount of energy. This is why it's very economical and good if we could use this for everything. Okay, here's what happens in a nuclear reactor. So take a look at some of the parts look similar to a coal burning power plant and some are different. So what we have here that's different is a reactor core. Inside the reactor core are some fuel rods that contain the uranium and that are bombarded with neutrons to create the heat. Here's my fuel rods. You can see them right here. They're bathed in water because it's very important that we keep them from getting too hot. And so we can see we've got water coming in over here, and then it's coming down and it's circulating around and it's going through that reactor core, and the water is heating up because of the nuclear reaction that's going on in the core. And then that hot water comes out here and produces steam in the steam generator, and the steam turns the turbine. And the turbine turns the generator, which is rotated through magnetic wires and produces the electrons that will make the electricity for you. And now you can see these electric lines going to power stations and carrying electricity to you. Okay, what's in that nuclear core? It is these fuel rods. These are little tubes that contain uranium pellets. So here's one fuel rod, and inside of it you can see all of these uranium pellets. Now I put a whole bunch of fuel rods together in a big assembly, and it looks like this rectangular piece right here. And inside of there are lots and lots of fuel pellets, and they go inside the reactor core. Now, in that fuel pellet, in that core, are not only the fuel rods, but these things called control rods. They're inserted in between fuel rods and they absorb excess neutrons because once this reaction happens, like I said, it's a chain reaction. It can go very quickly and it can get out of control. So we have so many neutrons happening here, bombarding all these nuclei, creating so much heat that we don't want it to get out of control. So we put the control rods in there, it absorbs the excess neutrons, and then we can keep this whole thing running, but not out of control. What happens if you do have a problem and you do get out of control? We can have something called a meltdown. So this is when the fuel rods get way too hot and they melt and the water boils away. And when I don't have any water bathing this system anymore, then it gets really hot and the radioactivity can be released. So here's the normal operation on the left-hand side. I've got a containment chamber. My reactor is inside of there. My fuel rods are in there. My control rods are in there. I'm creating hot water, which is making steam, turning my turbine. I'm getting electricity. That's great. Without water, let's say the water boils away. Look on the situation on the right in the red picture. The water boiled away. Now my fuel rods don't have anything to cool them down and they're going to overheat. And the reactor core is melting through the floor of the chamber. This is very bad. If this happened, radioactivity would be released and anyone who's living in the area around there could be contaminated with ionizing radiation. And that would be a bad thing. Okay, how do we get uranium? We got all these fuel pellets and the core of the reactor is made of uranium pellets. What do? We have to mine it from somewhere. So here we go back to mining again. It takes 900 kilograms of ore to produce only 3 kilograms of nuclear fuel. So we have all the same negative effects of mining that we have with mining coal or mining anything else, but much less uranium is needed for the same amount of electricity. So if you think about it, we do have to mine it, but we don't need quite as much as we do of coal. So maybe the impacts would be a little bit lessened from there. Okay, now go back to your world map and take a look at where we find uranium mines. So uranium output shown as a percentage of the top producers in these different countries, and the red ones are smaller and the green ones are bigger. So we've got Canada, we've got the Northeast US, we've got places in Africa, we've got Kazakhstan over here, we've got a big bunch in Australia and some in Northern and Eastern and Western Europe. Okay, this is a possibility that could happen, should not happen, but might happen. This is a Wyoming uranium mine threatening some drinking water. So what's going on here? If you mine for uranium, you need to get a permit to pollute the underground drinking water called an aquifer exemption. The mine is polluting here the shallow aquifer, and then it injects waste into a deeper aquifer using disposal wells. The wells can't be located above another drinking water source. So sometimes there's disputes about this, and sometimes there's questions about whether or not uranium mines could possibly threaten drinking water, depending on where the aquifers are and where the mines are. Okay, what are the advantages of nuclear energy? Guess what? There are no emissions. So no CO2, no methane, no sulfur, no mercury, no lead, no arsenic, no sulfur dioxide, nothing. Nothing comes out of a nuclear power plant as far as emissions that are greenhouse gases. However, you can't forget mining because mining has to be factored into this. So if mining, the operation of mining, creates any greenhouse gases or emissions, you kind of have to count that just a little bit. But compared to coal, look at coal, gas, and thermal and gas combined cycle. And what is this? Is this grams per kilowatt hour of CO2 emitted, and nuclear is almost none. Okay, I can produce a lot of energy this way. This is a huge advantage. It's very predictable. It's much more predictable than wind or sun. I know exactly how to do it. I just need a very small amount of uranium and I can produce a lot of energy. What are the disadvantages of nuclear power? The plants are very expensive to build. It takes a large initial investment, and for many years you have to try to recoup that cost. Because you have to have so many safety measures in the building of the plant so you can prevent accidents. So this is just very, very costly. There could be accidents. So there have been accidents that have happened in the past. We've got 3 that we're going to highlight for you that are kind of case studies of accidents that happened with nuclear power. Doesn't happen often, but it could. And then the third thing that's a disadvantage is you have to dispose of the radioactive waste. When those fuel rods get spent and they are done and they can't do any more nuclear reactions, they still have to be put somewhere, and they are highly, highly radioactive for probably hundreds to thousands of years. And so we just can't leave them anywhere because they would contaminate and make people sick. So those are the disadvantages of nuclear power. We will talk more in class about the accidents and the nuclear waste and what to do with it. And I hope that's helpful.